Jai Hind to all. My name is Manoj Kumar, Assistant Professor in Department of Computer Science and Engineering, Akgec Engineering College, Gadewal. Today, in this lecture, we will learn about the process concept in operating system. So, first we will see about the basic concept of the process, and after that we will see the process scheduling. So, what is process? Actually, process is a program in under the execution of the CPU. There are two terms, process and program. Program is basically a passive entity. Whenever our data or program is stored on secondary storage or hard disk, then it is technically known as the program. As soon as it is loaded into the main memory and CPU start to execute the instructions of that particular program, then it is technically known as the process. So, process is a program in execution. Okay, and whatever the process include, these are some attributes or parameter in context to a particular process. First one is the program code. Process include the program code, program counter, which basically contains the information or address about the next instruction to be fetched. After that, process register content, process stack. Every process maintain a stack which contains its local variable data. Okay, next one is the data section, which contains the information about the global. So, these are some attributes corresponding to a particular process. So, as process execute, now next term is the process state. Whenever a process start or begin to start, then from beginning to the completion of the process, there may be the several state of the process. It means process state may change. Okay. So, during the whole life cycle of a particular process, a process can remain in these states. First one is the new state, running state, waiting state, ready state, and the terminated state. So, when the process will be in new state, whenever a particular process is created, at that time, state of that particular process is known as the new state. Okay. Next, after that, next stage is the ready state. Ready state is that whenever a process is loaded into main memory, what it is waiting for the allocation of the processor or CPU. So, whenever a process is loaded into main memory and it is waiting for the CPU allocation, then at that time process state is known as the ready state. Once the CPU is allocated to the process available in main memory and CPU start to execute the instruction of that process, then process state change. Now, the process will be in running state. So, instructions are being executed. Whenever the instructions of a process are being executed, at that time, state of the process is known as the running state. Second, third state may be the waiting state. Suppose during the execution of a particular process, if that process requires some kind of input-output requirement from the user. So, until that input-output requirement is completed, the process state is known as the waiting state. So, if the process is waiting for some event to occur, or that type of event may be some kind of input-output request, completion request. So, during the execution, if process needs some kind of input-output, so until this input-output request is completed, process state is known as the waiting state. Last state is the terminated state. Whenever a process finishes its execution, then its state, it come into the terminated state. It means whenever a process is terminated, it means we generally say that it finished its execution or it completed its execution. This is the diagram, process state diagram or process state transition diagram. So, first stage is the new state whenever a process is created or submitted to the system. Now, whenever the process is loaded to the main memory, then it is the ready state, or here the label is admitted. It means, and this is the task of the long-term scheduler. Long-term scheduler is responsible to take the process from new state to the ready state. So, whenever a process is in ready state, then process is waiting for the CPU allocation. Now, there is another scheduler which is known as the short-term scheduler or sometimes also known as the dispatcher. So, this is the responsibility of the dispatcher or short-term scheduler to brings a process who is in ready state in running state. Okay. So, next stage is the running state. Whenever CPU start to execute the instruction of a process, at that time CPU will be in running state. Now, during the running state, there may be 3 tasks. This is our case 1, this is case 2, and this is case 3. In case 1, what will happen? Suppose a particular process is executing or under the execution of the CPU. If at that time process P1 is executing, okay. If at that time another process is submitted in ready state, the process P2, and the priority of P2 is higher than the priority of P1, or you can say that P2 is an urgent process. So what will happen? In that case, the execution of process P1 will be stopped, and this process P2 will be allocated to the CPU to execute. So this level is known as the interrupt. It means whenever a particular process is in running state or is under the execution of the CPU, if at that time any other process of the higher priority or urgent process submitted in ready state or submitted to the system, then execution of currently running process P1 will be interrupted, okay, and this process P1 will move to the ready queue or ready state. Now this process P2 will be in running state, CPU will start to execute the process P1. So this is the case 1. Case 2, suppose process P1 is running, and during the execution, if it demands or requires some kind of input output, so until this input output request is completed, the process will be in waiting state. As soon as the input output requirement is completed, then this process P1 will come to the ready state, okay, because during the time period, whenever the process P1 is in waiting state, the CPU is free. At that time, CPU may be allocated to other process, P2 or P3, and CPU will execute that process. So once the input output requirement of a particular process is completed, so it doesn't come to running state. It will always come to ready state. Why? Because at that time CPU is busy with other process, okay. This is the third case, whenever the process is executing and all the instructions of the process have been executed successfully. After that, process will come into the terminated state, and when the process will come into the terminated state, then memory space or resources allocated to the process will be taken away from that particular process and allocated to the some other process. So this is the basic process state transition diagram. Next one is the process control block. What is process control block? Process control block is known as the PCB. This basically work as a data structure for a particular process. It contains all the information about the process attribute, like what is the process state at a particular time, in which state the process is, either it is new, running, or ready, or waiting. What is the process state? That information will be available in the process control block, okay. Next one is the program counter. Program counter basically, in context to a particular process, store the address of next instruction to be fetched. So this information will be available in PCB of that process. If there are at a particular time there are 4 processes, then every process has its own process control block, okay. Next one is the CPU register. It means what type of registers are in use by a particular process. In the same way, the CPU scheduling information. It means the process are scheduled using which CPU scheduling algorithm. Either it is FCFS, either it is SJF, so test job first. So scheduling information is also available. So process state, program counter, CPU register, and the CPU scheduling information. All these information in context to a particular process is stored or available in the process control block. And again, some other attribute are the memory management information. It means how much memory space is utilized by that particular process. Some accounting information, some input output status information. It means which input output devices are allocated to that particular process. So all these information related to the input output, accounting information, memory management, CPU scheduling, CPU register, program counter, process state, this will stored in the process control block. So what is process control block? Process control block act as a data structure which contains the information about different attributes, or you can say that about the general information about the process, complete information about a particular process. Process number, it means what is the process ID. Whenever the process are submitted in the system, then operating system recognize a particular process from its process ID. Every process has a unique process ID. Okay, so this is the basic diagram of the process control block in context to a particular process. Next one is the different type of queue. Whenever the process submitted to the system and till it completed, there are different type of queue are used. Job queue. Job queue is corresponding to the secondary storage. It means whenever a program is on secondary storage, then this is the in job queue. A queue is a queue is maintained. Suppose there are 3 programs P1, P2, P3. Then these are in job queue. Next one is the ready queue. Once the program is loaded from secondary storage to the main memory. So this ready queue is corresponding to the main memory. And this is the task of long-term scheduler to pick the process from job queue and put them into ready queue. P1, P2, P3. This task is carried by the help of long-term scheduler. That is why long-term scheduler also known as the multi-programming degree controller. Long-term scheduler control the degree of multi-program. Multi-program means how many processes are available at a particular time in main memory. That is known as the degree of multi-programming. So, since the task of long-term scheduler is to pick the process from job queue and load them into ready queue or main memory. So, this depends on the long-term scheduler, how does fast it work. Okay. Second one is the device queue. Device queue contains the set of process waiting for input output devices. During the execution, if sometime the process required some kind of input output requirement, then how many processes are there? So that queue is known as the device queue. So those processes which require some kind of input output requirement, they will be maintained in a separate queue, and that queue is known as the device queue. So process migration between these 3 queues from starting state to the completion state, from new state to the beginning state. So job queue, ready queue and device queue, these are 3 important queues which are used during the process life cycle. Next one is the schedulers. Scheduler is long-term scheduler. As I already told that long-term scheduler select the process and brought into the ready queue. It select the process from the job queue and put them into the ready queue. Second one is the short-term scheduler. Short-term scheduler is also known as CPU scheduler, and sometimes it is also known as the dispatcher. Dispatcher is a module of the short-term scheduler that select the process from ready queue and allocate the CPU to them. Okay, select the process being executed and allocate the CPU. So this is the responsibility of the short-term scheduler to select the process from the ready queue and allocate the CPU to the selected process so that CPU can start to execute that particular process. Okay. So short-term scheduler is invoked very fastly. Long-term scheduler is invoked very infrequently. Or long-term scheduler control the degree of multiprogramming. As I already told that how many number of processes will be loaded into main memory, it depends on the working of the long-term scheduler. So process generally during the life cycle in context of the bound, it may be the input output bound and it may be the CPU bound. Whenever the process will be under the execution of the CPU, at that time it is known as the CPU bound process. And if during the life cycle process is waiting for an input output request, then at that time the CPU process will be known as the input output bound process. There is another term known as the context switch. So whenever the CPU switch from one process to another process, then the data or state of that particular process, suppose CPU, this is our process P1, this is our process P2. Now this is our process P1. Okay. So at this is 0, this is 1, this is 2 and this is 3. Suppose at time t equal to 1, process CPU will move from process P1 to process P2. But at time t equal to 1, process P1 is not completed. So status of this process P1 will be saved in the PCB of P1. Okay. So saving the state of a particular process in its PCB and switching to the next process, this task is known as the context switch. This context is basically represent the state of process at the time whenever CPU switch from that process to the next process. Again, at time t equal to 2, whenever the CPU will again start to execute the process P1, then it will save the state of process P2 in the PCB of P2. Okay, so context switch is a process whenever CPU switch from one process to another process, then it will save the state of previous process in its process control block, so that whenever it start to resume that process P1, then it will resume not from the starting, but it will resume from the saved state in the process control block. Okay, thank you.